Let's explore how to implement a star rating and review system in our Wagtail and Django-based newspaper project. This feature will greatly enhance the interactivity and user engagement on our platform. Let's dive in. Time to open your models file. We will begin by designing the database schema to store ratings and reviews associated with our content, and we consider including fields for the rating value, review content, user information, and the content being rated. Initially, we shall import max value validator and min value validator from Django's core validators module. It's essential to grasp the significance of max value validator and min value validator modules from Django's core validators collection. These modules will become steadfast companions throughout our tutorials, particularly within our e-commerce series. Now, with a sense of curiosity, let's delve into a comprehensive exploration of these modules using pure Python. The purpose of this code is to demonstrate how to create and use custom value validators in Python, specifically max value validator and min value validator. These validators are used to check whether a given value meets certain criteria, such as being within a specified maximum or minimum range. We start by designing the max value validator class to check whether a given value is less than or equal to a specified maximum value. The init method initializes the max value validator instance. It takes one argument, max value, which is the upper limit that the value being validated must not exceed. The max value is stored as an attribute self.maxValue of the validator instance. The call method is a special method in Python that gets executed when you apply the validator to a value. In this case, it takes a single argument, value, which is the value to be validated. Inside the call method, it checks whether the value is greater than the max value. If the value is greater, it raises a value error with a specific error message indicating that the value must be less than or equal to max value. The min value validator class, on the other hand, will be used to check whether a given value is greater than or equal to a specified minimum value. Similar to max value validator, the constructor of the min value validator class takes one argument, min value, which is the lower limit that the value being validated must not fall below. The min value is stored as an attribute of the validator instance. Like in the max value validator class, the call method is responsible for validating a value. It also takes a single argument, value, representing the value to be validated. Inside the call method, it checks whether the value is less than the min value. If the value is less, it raises a value error with a specific error message, indicating that the value must be greater than or equal to min value. Now let's create instances of these validators. Without specifying the maximum and minimum values they should validate against. We are testing the max value validator with a value of 1000. We define a value variable and set it to 10,000. Then we apply the max validator to the value. If the value is less than or equal to the maximum value allowed by the max validator, the validation succeeds, and the code inside the try block will be executed. But if the value is not within the allowed range specified by the max value validator, the except block will be executed. For min value validator, we also test it with a value of -50. We apply the min value validator to the value. If the value falls within the allowed range, the code inside the try block will be executed. However, if the value is below the allowed range, the code inside the except block will be executed, and a value error will be raised to signal the validation error. Let's establish the minimum and maximum values. For both of our validators, the max value validator will be set to 1000, signifying the upper limit, while the min value validator will be configured with a minimum value of 0, defining the lower threshold of acceptance. Now, let's execute this code and observe the output. If you are using Visual Studio Code on Windows, you have the option to run it using the play button or by pressing F5. As evident from the output, a value error has been raised, indicating that the value provided does not fall within the allowed range for either the min value validator or the max value validator. Now, let's rectify this by substituting the correct value within our validators. For the min value validator, we will set the value to 50. And for the max value validator, the value will be 1000. Now, execute the file, and as expected, the try block will be executed since all the provided values fall comfortably within the allowed range. That was a concise simulation of how Django's max value validator and min value validator modules operate. One of the aspects I appreciate most about Django is its ease of simulation, allowing me to grasp the fundamentals of various modules and then delve deeper into exploring their capabilities. Let's proceed by defining the schema for our reviews model. We're defining a Python class called review, and it's inheriting from models.model. The post field establishes a relationship between our review model and the post model. It's like creating a link between reviews and the posts they belong to, and we are using the foreign key attribute to achieve that. The related name attribute allows you to customize the name you use to access related objects, making your code cleaner and more understandable. And on delete equals models.cascade means that if a post is deleted, its associated reviews will be deleted as well. Here, we're defining a field called author as a character field. It can store the name of the person who wrote the review, and we're setting a maximum length of 50 characters for their name. Next field represents the rating given in the review. It's an integer field, and we're adding some validation with min value validator and max value validator to ensure that ratings are between 1 and 5. The text field is for the actual text of the review. It's a text field, and we're allowing it to be blank, meaning a review can have no text, or a lengthy one. Finally, we have a created field, which is a date-time field. We're using auto now at equals true, which means this field will automatically store the date and time when the review is created. Now that we've completed the setup of our reviews model, it's time to take the next step. We're going to create a forms.py file. In our application folder, in this file, we'll craft the form that our users will use to input their review information. First, we're importing the review model from our application's models. This is essential because our form will be closely tied to this model, and we need to access its fields and attributes. We'll also import the Forms module from Django. This module provides the tools we need to create and handle forms in our web application. Here, we're defining a list of choices for the rating field in our form. It's a set of tuples, where the first value is what gets stored in the database, and the second value is what's displayed to the user. In this case, we're offering rating options from 1 to 5. Now, we're creating a new Python class called reviewForm, and it's inheriting from forms.modelForm. This tells Django that we're building a form based on a model. Inside our reviewForm class, we define a nested class called meter. This class will contain some meter information about our form. We specify that our form is associated with the review model. This connection allows Django to automatically generate the form fields based on the model's fields. Then, we list the fields from our review model that we want to include in this form. In this case, it's author, text, and rating. This is where things get interesting. We're customizing the widget for the rating field. Instead of a standard input field, we're using a forms.radio select widget. This will display the rating choices as radio buttons, making it easier for users to select their rating. Now, it's time to integrate the form we've just crafted into our detail view. We begin by checking if the HTTP request method is post. In Django, when a form is submitted, it typically uses the post method to send data to the server. So, this condition checks if the form has been submitted. If the form is submitted, we create an instance of our review form by passing in the post data from the request. We then check if the form data is valid. This includes ensuring that the required fields are filled out correctly, and any additional validation rules we've defined in our form are satisfied. If the form is valid, we access the clean data. Clean data is the data that has been validated and sanitized by Django. It's safe to use and ready for further processing. The next line creates a new review object in our database. We populate its fields with data from the cleaned form data and associate it with the relevant post. Finally, after successfully creating the review, we redirect the user to the post detail page so they can see their review in context. Taking a moment to highlight this, because it's a question I've been asked before. How do we redirect to the same page? Well, my friends, here's the trick. When a user submits a form or takes an action that requires a redirect in Django, we can specify the URL we want to redirect to. In this case, we want to return to the post detail page after the review is submitted. So, we use the redirect function from Django, and we provide it with the name of the URL pattern we want to redirect to, which is home, detail, and don't forget, we also pass along any necessary parameters, in this case, the slug of the post. In a nutshell, that's how we seamlessly redirect our users back to the same page they were on, after they've interacted with our web application. So, once again, if any of you have questions or suggestions, please know that you are always welcome to reach out. You can drop your comments right here, or feel free to contact me via email. Your input and ideas are highly valued, and I'm here to assist and collaborate. Now, if the request method is not post, we simply initialize an empty review form for the initial view rendering. Finally, we render the detail.html template, passing in the post and review form as context data. This is what allows us to display the form to users who want to submit reviews. Now, we're ready to incorporate our meticulously crafted review form into the comments form.html template. To make things as smooth as possible, I've gone ahead and prepared some stunning star HTML elements along with their CSS styles. Please proceed by duplicating all the content within the star.html template. Afterward, paste the entire duplicated content into the comment form, positioning it just above the div element that carries a class attribute of input blocks. Now, let's relocate the custom.css file from the utilities folder to the CSS directory within the static folder. This strategic move ensures that our CSS file is in the right place and ready to style our web application effectively. Now, we have a set of star rating elements that users will interact with to rate something. To make these elements work seamlessly with our Django form, we need to add some crucial attributes to each input element. Name. This attribute identifies the name of the form field. It's crucial for grouping the radio buttons together so that only one option can be selected. Within the same group, in our case, we'll set it to rating to match our form field name. ID. The ID attribute uniquely identifies each input element. It's particularly useful for associating the label elements with their respective inputs. We can use a loop or a counter to generate unique IDs for each input. Value. We've assigned a value to each input element, where it represents the rating value 1 to 5. This value will be sent to the server when the form is submitted, indicating the user's selected rating. Type. We already have the type attribute set to radio, which indicates that these are radio buttons. You don't need to change this. Required. We've kept the required attribute to ensure that the user must select a rating before submitting the form. This enforces data integrity. Now, I invite you to carefully follow these precise steps as we meticulously assign attributes to each input element. This meticulous process is essential to ensure the seamless integration of our star rating interface with our Django form.
They tell me that I'm never gonna make it. They want me to do something that could make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. I got all this potential that's deep inside of me, but they hate when you're successful cause they try to be. They sit there being judgmental because you're trying things, and they just want you to settle and do the right thing. So get a good job, don't slack off. Wake up every morning, make a good impression on your boss. Don't do anything that I wouldn't do, and when you're making money, make sure you don't spend it too soon. Fuck that, I'll do what I wanna do. I got a different path from everyone, and that includes you. Who are you to tell me how to live life? In these times it feels like nobody is right, yeah. So I'ma figure out what else we succeed, and then invest all of my time into that and proceed. I need whatever the hell could make me happy, and I don't think you have a clue what could that be. They tell me that I'm never gonna make it. They want me to do something that could make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. They tell me that I'm never gonna make it. They want me to do something that can make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. I think this life could be special if I get rid of the devils. They think that I am a rebel, I think they want me to settle. There's nobody on my level, they think that work is too stressful. I think that work is essential, the grind is all in your mental. And I don't think you understand what I'll go through just to be in control of my life soon. All the negativity, man, I'm immune. I don't really need a mask with all I've been through. I've been making changes for the ages. 5-10 year plans are contagious. I attack that shit, I'm tenacious. And if you ain't, get the fuck out of my way then. Got one life, I won't regret it. I will fight until I get it. I'll look back one day from heaven and say, damn, I learned some lessons. And say, damn, I have no questions. I had fun in every second, and the journey was a blessing, yeah. They tell me that I'm never gonna make it. They want me to do something that can make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. They tell me that I'm never gonna make it. They want me to do something that can make sense. They hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing.
One important detail to keep in mind is the inclusion of the custom .css file in the head section of our HTML, linking it from the static directory. Don't overlook this key element. Now, let's take the next step by running the server. And at this juncture, it's imperative to verify the functionality of our form within the web browser. Initially, you'll observe the presence of the star rating inputs within the form. Now, let's embark on an interactive journey by attempting to complete and submit the form to witness its functionality in action. Now, having successfully completed and submitted our reviews form, it's time for the grand finale. We're about to unveil the magic as we elegantly render all the reviews on our detail page. Open the comment.html file located in the template directory, and together, we'll meticulously incorporate our context data into this pivotal template. We'll commence by strategically removing specific elements from our layout. Our objective is to retain only a select few, while preserving the others for their invaluable design purposes. We begin by using a Django template tag to initiate a loop. In this loop, we're iterating through each review object in the reviews related to the post object. Essentially, this loop fetches all the reviews associated with the current post. Observe the elegant utilization of the related name attribute as we access all our review objects. The review.author template variable dynamically inserts the author's name from the review object. The review.created variable fetches the creation date from the review object. Finally, we display the review text within a paragraph element. The review.text variable inserts the actual review text from the review object. After making the necessary adjustments, kindly save your changes, and then proceed to reload your web browser to verify if everything has been correctly implemented. As we carefully observe the current state, it becomes apparent that our comments are not being rendered within the template. However, I believe the root of the issue likely lies within the comment form itself. It's imperative that we meticulously investigate and pinpoint the origin of this problem to rectify it effectively. As anticipated, the issue has been uncovered within our form. It appears that we omitted the crucial name attribute for the author input, neglected to assign an ID to the text input, and there was also an oversight in specifying the ID for the author input. After making the necessary corrections, hit that refresh button on your browser. It's time to fill out the form once more and hit that submit button to witness if our diligent efforts have resulted in successful rendering this time around. Cool. It seems our form is now in much better shape. However, our journey is far from over. The next exciting step is to showcase the number of comments a post has received. Calculate the average of our reviews and elegantly display it. Yes, you heard it right. We're not done just yet. We are defining a method named getStarRange, which takes self as its first parameter in Django models. Self refers to the instance of the model that the method is called on. Inside this method, we are using the range function. The self.rating attribute represents the rating given to a particular review. This attribute holds an integer value between 1 and 5. Indicating the number of stars. If, for example, self.rating is 3, the range will create a range of numbers from 0 to 2 because Python ranges are 0 based. This effectively represents a star rating of 3 out of 5. So, when you call getStarRange on a review object, it will return a range of numbers corresponding to the rating of that review. And this is precisely what we're about to put into practice within our template. We are starting with a div element, which is given the class comment rating. This div will serve as the container for displaying the star ratings. Inside the div, we're using the for loop. This loop iterates over the result of calling the getStarRange method on the review object. This method, as we've defined it, returns a range of numbers based on the review's rating. For example, if a review has a rating of 4, this loop will iterate 4 times, creating 4 I elements for displaying star icons. Within the loop, we are using an I element to represent a star icon. The class attributes are used for styling and specifying the star icon. Finally, we close the for loop with end4. After creating the necessary number of star icons based on the review's rating. Now, go ahead and refresh your web browser. You'll notice that the stars are displayed based on the numeric rating. It appears we've encountered an issue once more. Not to worry. Let's investigate and address it promptly. It seems we overlooked iterating through the review objects. To resolve this, let's proceed with the necessary iteration. Please refresh your web browser once more. I assure you that this time, there won't be any further errors. Now, let's get the reviews counted per post. you're defining a method named getReviewCount, which takes self as its first parameter in Django models. Self refers to the instance of the model that the method is called on, which in this case is a specific post. Inside this method, we are using the reviews attribute, which likely represents a related set of review objects associated with the post. We are calling the count method on this related set. This code essentially counts the number of review objects that are associated with the specific post instance. It provides the total count of reviews linked to that post. Now, let's proceed to call this method within our template to obtain the total number of reviews for each post. Now, we're about to expand our horizons. Previously, we obtained the star range for a single review in the review model. However, this time, we're going to acquire the star range for all reviewers who have contributed to the post. Indeed, this broader perspective will provide us with a comprehensive view of the post's average rating. We'll harness this valuable insight to categorize our posts based on their star average rankings. We begin by defining a custom method called getAverageRatingScore within our Django post model. This method is intended to calculate the average review score for a specific post. We initialize a variable called AverageScore with a default value of 0. This variable will store the calculated average review score. We check if there are any reviews associated with the post. This conditional statement ensures that we only proceed with the calculation if there are reviews to consider. If there are reviews, we calculate the total score. Here, we use a list comprehension to extract the rating attribute from each review in the self.reviews.all query set. Then, we use the built-in sum function to add up all the individual ratings, resulting in the total score for the post. Finally, we compute the average score by dividing the total score by the number of reviews, which is obtained using self.reviews.count. This calculation yields the average rating for the post, representing its overall review score. Finally, we return the average score, rounded to one decimal place using the round function. In summary, this method calculates and returns the average rating score for a post based on the ratings given in its associated reviews. It ensures that even if there are no reviews, the average score is set to 0. This can be quite useful for displaying the average rating of a post in your Django. Now, Let's display our rating average count in both the comments and the detail page.